we are going to do the same thing that we did in the last one here. We are going to multiply the bottom of this by its conjugate to get rid of the i's out of the denominator, okay? So 3 plus 7i on top and negative 10 plus 2i on the bottom. What's the conjugate of that?
Negative 10 minus 2i.
Yep, negative 10 minus 2i. Okay, so we got to multiply top and bottom by the same amount. Which one's the conjugate? It's always the bottom, what's on the denominator, and you're always going to take just the second term of that. You're going to change the sign. Okay? So now let's use our box again. We have negative 3 and a 7i here. And we have negative 10 and a negative 2i here. So negative 3 times negative 10. It's positive 30. This will be negative 10 times 7i is negative 70i. Okay, negative 3 times negative 2 is a positive 6i. And then negative 2 times 7 is a negative 14i squared. So that becomes a positive 14 because the I squared is negative 1. Yep, 30 plus 14 is what? 44. And then negative 70i plus 6i. Yep, that's on top. So now remember, on the bottom, I'm really squaring the 10 and the 2 and adding them together. That's what happened. Remember that these terms canceled out here? So it ended up being 5 times 5, which is 25. And then I times I, which was I squared. Sure, I'll do it again. Let's just do it, and you'll see what I'm saying. Okay, so this will be negative 10, positive 2i, and then negative 10 minus 2i. So negative 10 times negative 10 is 100. Negative 10 times positive 2i is negative 20i. This becomes a positive 20i. And then the bottom becomes a negative 4i squared, right? So these cancel. This becomes a positive 4. And then 100 plus 4 is 104. So like I said, if you were to square the two terms and then add them together, that's what you would get, 104. Okay? Yeah, you have a question? No? Okay, yeah. Yeah, so 44 over 104 minus 64 over 104. And you can simplify those, right? I. Okay. Okay, so this was a nice little chart on your notes. Basically, it tells you about the different polynomials. This one you should be more familiar with. This is called a difference of squares, and we're going to talk about that in a minute. Why do you think it's called a difference of squares? Yeah, these are perfect squares, right? X squared is a perfect square, and 9 is a perfect square. So notice when you're factoring a perfect square and they have a minus between them, the factors are the square root of both numbers that are conjugate. Okay, let me repeat that. Perfect squares, two terms. This factors are conjugates of each other. They're the square roots. Do you guys see that? Okay. So x squared minus 5. 5 is not a perfect square, so you can't factor it, right? So in terms of integers, it doesn't factor, but if you had it in square roots, yeah, it still factors. And so the complex numbers are this. But x squared plus 36, it can't factor for integers or real numbers, but it can for... But, look, x squared equals negative 36 if you were to solve for it. And then the square root of a negative number, right? Okay? So, when you want a perfect, this is a perfect square and you have a minus sign here, that works to get without an I. But if it's a plus sign, it is an I. Okay?
No.
So, if you have a CAS, by the way, this is what you can use to factor. But on the test, I'm not going to let you use a CAS.
So what do you want us to do?
You're going to use the box method like I taught you the other day. Okay, so here's a couple things you need to remember. Remember that natural numbers are members of integers, which are members of rational numbers. Irrational numbers, both of these are members of real numbers. And then complex numbers comes beyond that. Okay? All right, so that is most